Hi, I'm Akshay, and we've been getting this problem that most of the kids just don't understand that why the angle of deviation is minimum when angle of incidence becomes equal to angle of emergence in a prism. Now, there's a very qualitative argument that if it were not so, then the same ray when it goes back from the right hand side to the left hand side, it will have then some other angle of deviation, and it will not be left with the same condition. Then it will violate our basic assumption. So that is one argument that says that only when the angle of incidence becomes equal to angle of emergence, it is that the angle of deviation is minimum. So we want to find it out quantitatively, and we're going to do this right now. So what you have is what we have is uh, that we have a given prism ABC, and angle of incidence is given. We have angle of incidence, then correspondingly angle of refraction is given, which is R1, and then there is this ray strikes on the front AC with the normal at an angle R2, and it comes out at an angle E with the normal, right? So what we want to do is we want to find what are delta R1 R2 in terms of A and everything. It is given that outside we have to assume that the refractive index is 1. We have air outside or space, free space, let's say vacuum. So what we have around this, what we have outside over here, this all region, we have mu equals to 1. However, on the inside, it is given that this is mu, right? So we're going to do something, right? What we're going to do is we're going to find some relations between A. Let us first find out what is the value of delta. Yeah. Now delta is exterior. Now let's see triangle FDE. In triangle FDE. Yes. Okay. Look very closely. This is FDE. We're talking in this triangle. We have that delta is equal to, which is exterior angle property of a triangle, it must be equal to angle D in FDE, angle D plus angle E. Now angle E can be written as I minus R1 because this angle, this complete angle was I, and there is R1 along DG line. So the left of angle which is along DE line will be I minus R1. So I minus R1 plus angle E, similarly we can write E minus R2. So we get as delta is I plus E minus R1 plus R2. We also have one more relation. So that relation corresponds to R1 and R2. So how do we find that? We know that R1 plus R2, right? R1 plus R2 is equal to 180 minus angle G, because in triangle DGE the sum of all angles must be 180. So we have this R1 plus R2 is 180 minus G. Also, what we know is that in triangle ADE, in triangle ADE, we have angle A plus angle D plus angle E must be 180, right? So angle D is nothing but 90 minus R1, because DG is the line which is perpendicular to AB. So the line joining D and E must make an angle 90 minus R1, which is angle D in this triangle. So angle A plus 90 minus R1 plus similarly angle E must be 90 minus R2. Yes, that must be 180. So solving this equation, what we get is that R1 plus R2 must be equal to angle A. thereby giving us that the angle of deviation must be I plus E minus A. Now, these are two things that we can establish very well, right? Let us say this is equation 1, this is equation 2. Equation 1 and equation 2, right? Let's move on. What other equations we know? We know Snell's law. So let's apply that. The equation says that sine I must be mu times sine R1. Let's call this equation 3. And we also have that sine of mu of sine R2 must be sine of E. Let's call this equation 4. So we have 4 equations, and to find what we want to find is we want to find the angle of incidence for which the angle of deviation is minimum. So essentially what we want to do is delta by di must be 0, because at minima the rate of change of delta with respect to angle of incidence must be 0. So if that is the case, put down the value of delta here. So what we get is d by di of I plus E minus A, where A is a constant angle of the prism. So which gives us that 1 is minus 1 is equal to dE by di. So we have also established this fact now. Let's call this equation number 5, right? Okay, now, so we know all this. Now let us differentiate equation 3. Differentiate equation 3 with respect to we want to differentiate I, right? So what we get is cos of I must be mu times cos of R1 dr1 by di, right? So we get this. Also, let us differentiate equation 4. So differentiate equation 4 with respect to I. Mu cos of R2 dr2 by di must be cos of E dE by di, which is minus 1 from equation number 5. This is minus 1. That gives us that dr2 by di is equal to cos of E by cos R2 into 1 by mu, and dr1 by di is equal to cos of I by mu cos of R1. So here this is 1 minus sign, right? This is, now we know that R1 plus R2 is A from equation number 2. So if R1 plus R2 is A, we know that R1 plus R2 is A. This gives us that dr1 by di plus dr2 by di again must be dA by di. However, A is a constant, so it must be 0. So adding these two, we must get answer as 0. So cos I by mu cos of R1 minus cos of E by mu of cos R2 must be 0, right? This must be 0. Essentially giving us that cos of R2 into cos of I must be equal to cos of R1 into cos of E. Okay, so we have this relation with us, and now what we're going to do is we're going to use this relation. So let's square this, okay, because we know sine of R2, sine of I and everything, right? So let's square this. So after squaring, after after squaring, what we're going to get is cos square R2 cos square I is equal to cos square R1 cos square E. Okay, So let's 1 minus sine square r2 into 1 minus sine square I is equal to 1 minus sine square r1 into 1 minus sine square e. So everything that we know we have. Okay, so we have that. Now let's put in the value of sine I from equation number 3 and sine e from equation number 4. So this equation becomes 1 minus sine square r2 sine square I must be from equation 3 mu square sine square r1, 1 minus mu square sine square r1 must be equal to 1 minus sine square r1 into sine square e from equation number 4 must be mu square sine square r2, 1 minus mu square 1 minus mu square sine square r2, right? So this is the final equation which we have. Now for in order for this to be true, in order for this to be true, we have only one condition in which case this is going to be true, and that is the condition is mod of sine r1 must be equal to mod of sine r2, right? Or in other words, what we can say is r1 equal to r2. And if that is the case, then from comparing equations 3 and 4 again, from comparing equation we get sin I equal to sin E, which is this implies that I is equal to E. So for such a case, if we want that, we started off with one assumption that we want our angle of deviation to be minimum with respect to angle of incidence. So with that we have come to a conclusion that I must be equal to E in such a case. And also if that is the case, we can also find the value of that, which is if r1 is equal to r2, let us say this is equal to r and I is equal to E. So delta is 2I minus A, which implies that angle of incidence delta minimum, angle of incidence will be delta minimum plus A by 2. Okay, and this again would be angle of refraction, right? Also we have that r1 plus r2 is A, so 2r is A. This implies that A is equal to, this implies that r is A by 2. So the condition again in that case which we get is putting these values in equation number 3 sine I. So let's write that beautiful result. It says that sine of I, sine of delta minimum plus A by 2 sine I must be mu times sine R divided by sine of A by 2, because mu times sine R is A by 2. So this is also a valid result. And we can extend such results, but let's be assured that mathematically also we can find this out, and it's really easy. I hope if there's any problem, please get back to me. Please try to contact me. I will readily help you out in any situation. Right? Thank you.